Math 9. We'll pop back in for the second half of the final lesson in Chapter 4. I wasn't able to do it all in one go. I had a couple of responsibilities. So we'll get going with this. And what we've got left over are combination problems. This hits home. Combination locks, we use them all the time. You have combination locks on your locker. You have combination locks for your bicycle. And the name of the game is to have the more combinations you have, supposedly the harder it is to bust into your locker. And of course, there's always ways around this. Someone sees your combination. Um, you see this data stealing all the time, right? Got to get your PIN code on your bank card. Okay, let's look at how we try to make the odds hard for perpetrators. Anybody who'd want to rip us off. Oh, we'll stick with purple. What the heck? A typical bike lock, if you look at the bike locks where they have the little sliders, they'll look like four little numbers like this. Those numbers can go from 0 to 9 on a couple of these sort of standard cylinders. What we want to do is we want to figure out, well, how many combinations are there total? Sounds like a stats question, doesn't it? First thing you have to identify is that 0 to 9, if you start counting at 0, because they're counting it as a value, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's really not much different than counting to 10, is it? Because there's 10 values total. So now that we've kind of got that realization, let's pop back and say that there are 10 possibilities every time that you put a value in. Now, when you draw it like this and you think for a second, it dawns on you. This whole chapter is about exponents. Well, heck, there's 1 in 10 choices I can make there. 1 in 10 I could make there. 1 in 10 I could make there. And again, 1 in 10 I could make there. Or we could say that there are 10 to the 4th possibilities. Easy way to write out what the number is. When you're multiplying by powers of 10, put the number 1 and then count the number of zeros. Or just look at your exponent. 10,000 possible combinations on a bike lock that's numbered 0 through 9. So you look at that and you say to yourself, I can see why they've got those bike locks that you see at Walmart and you see for sale at Staples and all these various places, where they're not only numbers but they're letters, because there are 26 letters in the alphabet, or funny symbols. Right? You could have a hashtag or a plus sign or a minus sign or one of these. I've seen these rather bizarre bike locks where you try to make it even harder. But you got to remember, if there's 4 things you have to get right to get the combination, well, that's pretty good. 10,000 possible combinations. There's a question in your assignment about the standard lock you see on our locker, and there are 60 possibilities. It's like a clock. It goes from 0 through to 60. Well, that makes it really hard, doesn't it? Because you could choose the same number could be chosen more than once, but the difference is you only pick 3 numbers. That's interesting. You only have to come up with 3. That's 1 less trial. That makes it a little less hard, doesn't it? That's like 1 less multiplication. This bike lock, 10,000 combinations, you would think that that's pretty tough. It's not as hard as you think. So, as we've gone through this, we've in fact done this repeated multiplication was there. And as a power, well, we already wrote that as 10 to the 4th. Comes out to be 10,000 possible combinations. Moving on up. You'll see formulas use exponents all the time. Here's one where someone's skydiving. So the distance that they're falling in meters depends on the amount of free fall time in the sky. That free fall time. Now I'll let these calculate these yourself, but once you get your sea legs under you in mathematics, when you see formulas, you'll just go right after them. The formula is that distance is 4.9, that multiplier, multiplied by whatever the time is squared. So here we go, 2 seconds squared. So this is our first example. And our second example, distance is equal to 4.9 multiplied by 4 squared. And you can see that this value when squared makes a very big difference. This is 4.9 multiplied by 4. Pay attention to what's being squared, because the longer you free fall, well, the farther you go. 4.9 times 16. When you multiply those values out, you will see a drastic difference in the overall distance. And that's as it should be. You've been falling longer. I'll let you crank that out on your calculator. Save a little bit of time. Along comes a surface area of a cylinder question, and it implies that you remembered something from grade 8 about how a cylinder was calculated in the first place. If you take a piece of paper like this and you begin to fold it, curve it upwards, you are in the formative stages of creating a cylinder until you curl it all the way around like this and it touches. Now, interestingly enough, I'm going to change colors here for a second. I always show my students the proofs of where these formulas came from, because you should see it. When we think about length times width, the area of a piece of paper, that's length times width. It just looks weird when it starts curling like that. Could easily be figured out. However, when we curl the piece of paper around like this, once the width is curled around and touches, I'll just hit undo there for a second, what we're looking at is the distance around the outside of a circle. Well, that is circumference. Circumference is equal to 2 pi r. Some students don't see this, but I always say, well, the 2 pi that's a full distance around the outside of the circle. How about we multiply pi times diameter, because 2 radiuses give us a diameter. So you often see this formula two ways, 2 pi r or pi d. And that goes back to an old formula you probably saw in elementary school, that the circumference of a circle is a trip around the outside of the rim. And there's a very neat proof, because when you learn about where pi came from, pi has a heck of a lot to do with circumference. And just so you know, just so you never forget where this formula came from, just do a little bit of magic here. Pi is the circumference divided by the diameter. Let me put it this way. It is always 3 times further This is where the formula came from. It took me a second to write it. But the distance around the outside, it's 3 times as far that way as it is to go straight across. And if you ever get a chance, take a piece of string and find this for yourself. All you have to do is measure around the edge of the can and divide it by the distance straight through the middle. You keep getting this number. It's 3 times as far around the edge as it is through the middle. We noticed that, and by we have to go back to Pythagoras, because he noticed it, and he came up with this neat value, and he said, well, I've observed a property of nature, and it will be forever called pi. going back to the question, because I wanted to see where that came from, you're given a surface area of a cylinder. Well, the surface area of a cylinder, assuming I have enough space for this now, I'll do my darndest. Let's choose a different color. Sort of need a formula for this. Let's see if I can fit her in. Surface area, there's two circles, the top and the bottom, right? There's one there too. So you have to consider those areas. There are 2 pi r squareds. That's the area of a circle. Plus, you have to consider the area of the original rectangle. Well, the rectangle, the width, we saw that the width here, once this is curled around, becomes circumference. It becomes 2 pi r. So I'm going to write that. We've got 2 circles plus the width, which is 2 pi r. And since width gets multiplied by height, we say 2 pi r times, let's call this height instead of length, 2 pi rh, like that. That's where the formula came from. We give you the formula, but this is it. 2, and to be brief, I'll use 3 for pi. 2 multiplied by 3 multiplied by, the radius in this case is 7. They gave it to you up here. And we'll add that to 2 times 3 times the radius, and the height is given to you as a height of 12. As I start to run out of space here, your final answer, if we take this a little bit further, 6 times 49 plus 6 times 7 times 12. Once these values are added together, you will have your area, and I'll have to apologize for running out of space, but you will have your area, total surface area rather, of 2 circles, and you'll also have the area of this. So let me color this in. This value is this, and these 2 circles, let's choose a, well, I guess I should choose a different highlighter color. I always love, undo. Lost my highlighter color. You have to say done, otherwise it thinks you want to change them all. There we go. So that was basically our rectangle. And if I do this correctly, nice orange, a little bit of a fade. That's about what I wanted. Ha, that looks pretty good. Maybe a little stronger. Our circles are figured out on that line. So give you a chance to crank out the answer for that. And if you're peeking in behind there, the assignment is sneaking right there, right above that little bit of figuring. So I ran out of canvas, but this is just one of those surface area of a cylinder questions, and it comes right down to it. It's 2 pi r squared plus 2 pi rh, or as some people know, 2 pi r squared plus pi dh. 2 radiuses make a diameter. Whichever formula you'd like to use is up to you. This is the one that I appreciate, that I know quite well, and I like it because I think that students get the idea of where the formula came from and they get comfy with it. Okay, so that's part 2 of the lesson, and I hope that helped out. Okay, ladies and gentlemen, have a good morning, evening, afternoon, whatever it may be.